Hello, everyone, and welcome to the first webinar in our 2023 Building Decarbonization Tech Series focused on building envelope retrofit. My name is Katie Kaluzny. I'm the Associate Director at Illinois Green Alliance, and I'm really excited to have you guys all here today. Today's program was organized by the Illinois Green Alliance in partnership with the Canadian Consulate General of Clean Technologies and Infrastructure teams. You have all been muted upon entry, so please type any questions you have into the Q&A, and we'll answer them throughout the discussion. We'll answer them in writing if there's time, and we'll answer them at the end during moderated discussion if we're able to. This webinar is being recorded and will be sent out as a follow-up email afterwards. Just a little bit about the Illinois Green Alliance. Illinois Green is a membership-driven nonprofit organization that advances green buildings and sustainable communities for all. Our strategic plan pushes the green building industry to meet or get on the path to net zero. And we achieve this through our work like educational programs such as today, engaging with communities and partnering with folks such as our partners today, and advocating for new policies and legislation. You can review any of our webinars in our on-demand library at illinoisgreenalliance.org. We're really excited, especially to be focused on this session today around building decarb tech, because it's really great to see the different technologies that people are advancing here in the space. I just want to take a moment to recognize Illinois Green Alliance's sustaining sponsors who make our work possible. A special thank you to our gold level sponsors, ComEd, Resource Innovations, and Sloan. You can make commitment to advancing green buildings and communities throughout the state, and always contact us if you're interested in sponsorship of our program. I'd like to give a special thank you to the Canadian Consulate General in Chicago for partnering with us on this event, especially the folks in Chicago, Minneapolis, and DC, Anne, Allie, and Kate, who have been integral to helping us plan this program today. It's been a pleasure to work with all of them and find the amazing panelists we have for you here today. I'd like to turn it over to Samir Ahmed from the Consulate General to say a few words about the Canadian Consulate. Samir?
Thank you very much for your kind introduction, Katie, and your warm welcome. Hello and bonjour. I'm delighted to be joining you this afternoon, and I would like to acknowledge my colleagues, Anne here in Chicago, Ali in Minneapolis, and Kate in the Embassy in Washington, as well as colleagues from the Government of Ontario and Export Development Canada, which is Canada's Exim Bank. We are absolutely thrilled to be hosting this, the first of a two-part summit, the Building Decarbonization Technology Series with our partner, Illinois Green Alliance. I'd like to thank Illinois Green Alliance and especially Katie Kaluzny and Twyla Neely-Strait, as well as our esteemed moderator, Kelly Adiji. This year, the Canadian Consulate General in Chicago is celebrating our 75th anniversary. We're taking a moment to look back at all we have achieved to build strong, deep, and long-standing linkages with the US Midwest, especially in the areas of infrastructure development and particularly environmental protection. As you may know, Canada is a known leader in the area of energy-saving building retrofits. More than 51,000 Canadian firms offer energy savings technologies and expertise globally to residential, commercial, industrial, government, and utilities, running the full spectrum from building performance, energy efficiency software, energy efficiency consulting services, and smart technologies. Of those more than 51,000 Canadian companies, we are pleased to have three to present to you today: Cascadia Windows and Doors, QEA, and Unitiwall. I'm looking forward to their presentations. Our role at the Canadian Consulate and throughout our network here in the United States is to help facilitate introductions to our world-class Canadian technologies through today's session. Let us be your first point of contact should you seek innovative solutions for your upcoming projects. As we look forward to the next 75 years and beyond, The work that we do as nations and you do as companies and in the private sector will be critical. As our nations work toward meeting our Paris Agreement commitments and net zero targets by 2050, and recognizing the critical roles of technology innovation and investment in enabling global net zero ambitions, Canada will continue to work with the US to fight climate change, with a focus on the key priorities of cutting emissions and aligning our approaches on the transportation and infrastructure sectors, coordinating progress towards sustainable, clean, and resilient infrastructure while conserving nature. I'm looking forward to today's session. Thank you for joining us. Merci. Thank you.
Thank you so much, Samir. I really appreciate the partnership again. We've done this for several years, and I'm excited to continue it into next month as well. I'd now like to introduce Kelly Adije, Senior VP and Director of Commissioning at Bauman Consulting and Illinois Green Alliance board member. Kelly is the moderator for today's session. Over the past 10 years at Bauman, Kelly has served as a key component in multidisciplinary design teams and specializes in the commissioning of large-scale international projects. Prior to joining Bauman, Kelly earned international project design and construction experience working for Arup and BDSP partnership in London, engineering, PZM engineering in Zurich, Switzerland, and many, many other projects throughout the way. It also has always been a great supporter of Illinois Green. So super thankful to have Kelly back as our moderator for this series this year. I'd like to turn it over to him and introduce our first speaker and share a few words about the program today.
Thank you, Katie. Thank you, Katie. Much appreciated for the introduction. Hey, everyone. Excited to kick off the third year of the Building Decarb Tech series with Illinois Green Alliance, our partner, and the Consulate General of Canada. The series allows us the opportunity to dig into the building energy and carbon solutions that exist and are emerging, and share how we can spread such awareness to incorporate these ideas into more buildings and projects across all our regions. With a focus on Canada in this session, I wanted to introduce some quick facts, fun facts about our neighbors from the north that were shared with me by the Consulate General of Canada. All right, fact one, Canada has a population of about 38.25 million and is the second largest country in the world after China. It's larger than the United States, for those who don't know. Did you know that more than 90% of Canadians actually live within 150 miles of the US border? Sure, some people didn't. Number two, Canada is actually the world's largest exporter of electricity and the sixth largest electricity market in the world. Major assets for that include large-scale hydro, small-scale hydro, nuclear, other renewables, hybrid and fossil, with cold weather solutions, and a sophisticated grid integration using smart grids and power storage. I think for those in the United States, we hear about what happened in Southern California, in Arizona, in Wyoming. I think as of yesterday, there were 785,000 people in the United States who were without power due to the storm session that we just experienced in that region. Anyways, back to Canada. So in 2020, 83% of Canada's electricity came from non-greenhouse gas emitting sources. Hydro makes up about 60% of that. And Canada is actually the third largest producer of hydroelectric power in the world. Nuclear makes about 15%, and other renewables somewhere around the 8%. Through those power sources, Canada is actually able to export about 10%, which is equivalent to about 72 terawatt hours of its electricity output, through an extensive network of high voltage lines. For those who don't know, a terawatt is 10 to the power 12 watt hours, basically a billion watt hours. Going into the building sector, Canada actually has the third most LEED projects in any country. It's just behind the US and China. There are over 4,000 LEED certified buildings and another 8,000 registered for accreditation as of 2019. Canada is also home to nearly 20% of the world's well-certified buildings. And as we know, buildings account for about 40% of the global energy consumption and about 20% of the greenhouse gas emissions, with about 50% of those coming from heating and cooling energy requirements, period. So global green building materials market is actually expected to be in the region of about $432 billion by next year, And right now, Canadian firms are demonstrating world-class abilities to be able to actually engage in that market and provide the solutions for the future world. So with that, I'd like to thank our 3 companies for joining our series and sharing their building envelope solutions with our members and partners today. I'd like to start by introducing Mike. Mike is president of Cascadia Windows and Doors, and is a recognized leader in building envelope technology innovation and commercialization. Cascadia, which is based in Vancouver, British Columbia, has innovated and commercialized some of the most remarkable building envelope technologies in North America. Let's welcome Mike to share more about Cascadia and their building envelope solutions. There you go, Mike.
Great. Hello, everyone. Can you all hear me?
Yes, indeed.
Excellent. So I'm just going to share my screen here. And can you see my PowerPoint presentation?
Perfect.
Perfect.
Excellent. Okay. Well, thank you everyone for having me here today. My name is Mike Battistel and I'm the president of Cascadia Windows. Also on the line as a panelist is our technical director, Michael Bousfield, who is able to answer any questions on the chat box as the presentation goes through and afterwards. So Cascadia is a building envelope technology company based out of Vancouver, Canada. And our mission is to lead North America's transition to energy efficient and durable building design. So our purpose is to innovate and commercialize building envelope products that enable buildings to achieve net zero energy efficiency levels. Some examples of our products include the Cascadia Clip, which was the first of its kind fiberglass thermal spacer ever developed for increasing the thermal efficiency of exterior insulated walls. The Passive House certified Universal Series window, which was the first PHI Passive House certified product ever designed in North America, and our fiberglass window wall product, which is a hybrid fiberglass aluminum product capable of spanning over entire commercial construction facades. So why do we focus on buildings? Well, buildings use a lot of energy, and they are actually responsible for about 45% of all CO2 emissions in North America. And when you look at the existing building stock in North America, the average building envelope heat loss resistance is incredibly low. So everybody on the call likely knows the definition of R value. That's essentially the measure of heat loss resistance. And when you look at a bag of batt insulation, let's use as an example, it'll say something like R20 or R14 or something like that on the bag. Now that is the nominal R value of that insulation. That's the R value of the insulation itself, the heat loss resistance. Effective R value is the overall R value of an assembly if you take into consideration all of the materials that extend through that insulation. So for example, in an exterior wall assembly, you may have steel studs that extend through the insulation, you have air films, you have other materials such as drywall, etc. So that is the effective R value of an assembly. So looking at these 3 buildings that we have on the screen, what would you guess would be the overall effective R value of the entire building envelope of these 3 buildings? So that would include the exterior walls, the windows, the roofs, everything that forms the building envelope. I'll just describe each of the buildings briefly. And if you can just jot down in the chat bar what you estimate or what you think the effective R value of the entire building envelope would be. After I describe each 3 buildings, I'll let you guys know generally what the effective R values are. So the building on the left-hand side, this is the Marine building in Vancouver, Canada. This building was constructed in the late 20s, finished off in the early 30s. At one point in time, that building was the tallest building in the entire British Commonwealth. So the exterior envelope consists of brick veneer over several other brick withes. There's no insulation in the walls. The windows were originally wood frame windows. They were replaced with aluminum frame windows back in the 80s. So what would you think the overall effective R value of that building envelope would be? Moving on to the next building. This building is called the Belmont Condominium, also in Vancouver, Canada. The exterior wall consists of mass concrete construction with steel stud inboard of the mass concrete with batt insulation in the stud space. The windows are thermally broken aluminum double glazed windows. So again, what would you guys guess the overall R value would be? And then lastly, we have the building on the right, which is a more modern building. This was constructed in the early 2000s. It has much larger glazing area, so more window area. The windows consist of aluminum thermally broken window wall. It has various concrete projections from the concrete slabs that jut out through the fenestration system. So what would you think the overall effective R value of that building would be? So the answer, all 3 of these buildings are somewhere between effective R2 and R3.5. So probably a lot lower than most people anticipated. So another interesting point is that the building on the right that was constructed in the early 2000s and the building on the left, which was constructed, finished off in the early 30s, the effective R value is not much different. In fact, the one that was finished off in the early 30s is probably slightly better than the one on the right. So the largest contributors to heat loss in these buildings and in most existing buildings in general are, number 1, unequivocally, without a doubt, windows are the lowest performers in the entire building envelope. And number 2, the exterior walls. So the illustration on the right, it kind of shows a common exterior insulated wall assembly that was conventionally used for many, many years. So we have created an online calculator on our website that enables designers to play around with different assemblies that have different effective R values to determine how to increase the overall effective R values of the entire building. And I'm just going to switch to our website here, and hopefully you can all see my new screen.
Yes, looks good.
Excellent. So I'm just going to give a couple of examples. So on this R value calculator, basically what you do is you plug in the effective R value of the core assemblies of your building envelope. So let's start off with the walls. So let's say we have an effective R value of our exterior walls at R15. In the Vancouver area, this is conventionally what was used as an effective R value for a number of years. And let's say that your exterior walls form about 50% of your entire facade. And then let's say you're using aluminum double glazed windows, which have an effective R value of roughly R2.25. Let's say that they make up 30% of the facade. And let's say your roof has an effective R value of R40, and that makes up the remaining 20%. So the overall effective R value of this building envelope would be about R 5.83. So not even R6. Pretty poor, but in general, that's better than most existing buildings out there. So let's say you wanted to substantially increase the effective R value of your building envelope. So let's replace that double glazed aluminum window with a double glazed fiberglass window, which has an effective R value of roughly R 4.5. So just by making that one change, we've moved from an R6 to almost an R10. So a pretty large impact on the overall effective R value of the whole building envelope just by making that one change, just by changing the weak link, the weakest link in the entire building envelope. So let's go one step further and change that double glazed fiberglass window to a triple glazed fiberglass window, which is roughly R 7.1. So as you can see, it gets us to R 12.4. So an even larger impact. So let's say you had your heart set on those double glazed aluminum windows and you wanted to get your large gains some other way. So let's, as an example, let's just double the effective R value of the exterior wall. We'll take it from R15 to R30. So before I do that, just note here that the effective R value right now is R 5.83. We changed that R15 effective to R30, and it doesn't even give us an increase of R1. Why is that? Because the weakest link, that almost all the heat loss takes the path of least resistance, which is the weakest link, usually the window assemblies. So you can get your biggest gains by improving your weakest assembly. So going back to the PowerPoint here. So we've created fenestration products that enable you to get up to those high energy efficiency levels. This is our Universal Series PHI Passive House Certified product. This was actually the first PHI Passive House Certified window ever designed in North America. It is designed for both residential and commercial applications. The building on the right is a good example of a building type that this product is often used for. We also have a window wall product that is primarily fiberglass, but is a bit of a hybrid between aluminum and fiberglass. Essentially what this product is our standard Universal Series fiberglass window with an aluminum extender on the exterior side of it. And this aluminum extender forms into a bypass and spandrel areas so that you can cover the entire facade of a building. So this product can be used on combustible and non-combustible construction, and it's the first of its kind fiberglass window wall system. I'm not going to go through all of our performance stats for our fenestration products, but in summary, we can hit U values as low as a 0.13 with these products. And in addition to that, through the NAFS testing that we've done, we've achieved performance classes of CW and AW classes, which enable these products to be used on some of the tallest commercial buildings in North America with no issues. In addition to that, it meets the Living Building Challenge Red List Free criteria, indicating that it has no substantially toxic materials in it that are detrimental to the environment. In addition to our fenestration products, we also have the Cascadia clip, which, as I mentioned earlier, is the first of its kind fiberglass thermal spacer for exterior insulated walls. Conventionally, exterior insulated walls had Z-girts that extended all the way through the insulation, negating about 50% of the effective R value of the insulation. With these fiberglass spacers, it greatly reduces the conductivity and separates those steel Z-girts from the rest of the building, and negates very little of the insulation's effective R value. This product can be used not only on exterior insulated walls, but it can also be used on exterior insulated sloped roofs and soffit assemblies. So with these products, we've been fortunate enough to work on some of the early net zero type projects as far back as 10 and even 15 years ago. So the project on the left-hand side is the Harmony House. So this was the first net zero project ever built on the west coast of North America. The project in the center was actually the first commercial passive house retrofit project in the United States. That was probably done around 2010. And then on the right-hand side, many of you might be familiar with this project. This is the Bullet Center, which is the first of its kind Living Building Challenge net zero commercial project in Seattle, Washington. So in addition to these early on net zero projects, we've had the opportunity to work on a number of deep energy retrofit projects. And this is actually that Belmont project that I described a little bit earlier when you were guessing the different effective R values of those three buildings. This was actually the center building. So with this deep energy retrofits, many of the utility companies in Vancouver were involved, and there was a building envelope engineering company called RDH Building Science also involved. They did some monitoring of the building before, during, and after the deep energy retrofit. And essentially, what formed the deep energy retrofit is we replaced all of the double glazed aluminum windows with triple glazed fiberglass windows, and we overclad all of the mass concrete wall areas with our Cascadia clip, 3.5 inches, and 3.5 inches of rock wool insulation. We managed to reduce the space heating energy by 90%. And reduce the heating costs from $17,000 a year to $2,000 a year. So pretty good payback on this building. If anybody wants to learn more about it, it's a pretty famous deep energy retrofit. There's a number of articles and studies on it online. So just type in Belmont Deep Energy Retrofit. Another interesting one was the Ken Sobel Tower in Hamilton, Ontario. So this is actually the world's largest PHI passive house retrofit project. Interesting project. It was a social housing building and it was in pretty rough shape. So they vacated the building and implemented this deep energy retrofit. The first step in the deep energy retrofit is they cut off all the concrete balconies. They were one of the biggest thermal bridges on the building, so they just cut them right off. Then they overclad the building using exterior insulation, and they replaced all of the existing windows with our triple glazed passive house certified fiberglass windows. They wanted to retain that connection between the residents and the outdoor space. So not having balconies, they wanted to create that connection some other way. So they designed quite large tilt and turn windows and incorporated a guardrail directly outboard of the operable vents. So the windows open really wide, there's no fall hazard, and it creates that nice connection with the outdoor space. In addition to deep energy retrofit projects, we also do a lot of just standard window replacement projects. So this one, for example, is the Pacific Point 2. It is located in Vancouver, and it was mandated by the city of Vancouver to have the aesthetics of the facade be pretty much exactly the same as it was before. So we managed to do that. The owners selected double glazed fiberglass windows to try and save some costs over the triple glazed. And the exterior walls were overclad with the Cascadia clip and rock wool insulation. So even though this is not technically a deep energy retrofit project, just by making those two changes, more than doubled the effective R value of the entire building envelope. The last item, and arguably the most important one, is that not all building envelope products are created equal. One variable that's often overlooked is the durability of the products. So usually when a deep energy retrofit is taking place, everybody's looking really carefully at what product has the highest R value or the lowest U value, but they're not looking as closely as how long these products are going to last. And when you're spending millions of dollars on these deep energy retrofits and you're replacing windows, you don't want to be doing that every 20 or 30 years on a building. That's not constructive, and that's not good from an energy perspective either. So selecting a product that has a longer durability has long-term energy efficiency benefits. So an example, our windows have a life expectancy of about 80 years, whereas conventional PVC products have a lifespan of less than half of that. So instead of replacing your windows, 3 or 4 times throughout the entire life of a building, it's better to do it just once or twice. All right, so with that, I will hand it back to Kelly. Thank you.
Thank you, Mike. That was a fantastic presentation. I really appreciate it. And I'm glad everyone really enjoyed it. To everyone, real quickly, please add your questions to the chat for Mike and Cascadia, and we'll get to them after all 3 presenters have finished their slides. We're going to go to the next presenter. I'd like to introduce Pevend. He's the CEO of QEA Tech. QEA Tech is based in Markham, Ontario, but Pevend is actually on a trip in Egypt right now, so he's in a much warmer spot than the rest of us are, or most of us anyway still. So Pevend is a highly accomplished entrepreneur and angel investor who has successfully launched multiple businesses. QEA Tech was launched in 2018 to help building managers and owners have the visibility over their building envelope and infrastructure assets. Let's welcome Pevend and Justin to share more about QEA Tech and how they are outsmarting energy loss through the building envelope. Over to you, Pevend.
Thank you very much, Kelly. Can you hear me right?
Yes, we can. Yes, we can.
All right, thank you. I apologize if I have not a great internet here. Thank you very much for having me today. I'm going to share my screen with my presentation and jump into what we do at QEA Tech. Please confirm if you see my screen.
Yep,
so
looks good.
Thank you. So my name is Pevend Lati. I'm CEO of QEA Tech, or Quantifiable Energy Audit. I was very excited listening to Mike's presentation and also John that is coming after me. What we do in QEA Tech, our focus is just to focus on energy loss from building envelope and see if we can collect data around what is the energy loss on the building envelope. So as we know, more than 40% of total GHG emission globally is related to the buildings. As Mike, I was looking at Mike's presentation, he presented 45% in North America. And there's a huge push for doing retrofit and deep retrofit programs around the world, which helps our technology and also solution providers for that. Theoretically, if we put a passive building envelope on top of any building, we can save up to 80% of this energy. But we all know that this is very expensive and capex. So at QEA Tech, we looked at the market and we found that there's very little data exists in the market on building envelope. We do a lot of basically estimation and also considering energy modeling to figure out what is the performance or thermal performance of building envelope, but we don't have detailed data of where is the problem in our building envelope. This is the largest assets that we have in our portfolio, and how we can prioritize our budget around where we want to attack in this large projects around building envelope first. Problems around building envelope is huge. We can have failed windows, frames, and not having insulation, moisture penetration, all kind of different problems in building envelope that some of them is related to energy saving, some of them is related to the risk mitigation. So at QEA Tech, we developed a software that we can provide this data to property manager, asset managers, engineering companies to make data-driven decision on these larger assets that they have in their portfolio, and create a roadmap to make data-driven decision on the investment on building envelope, and also do risk mitigation around continuous improvement that this basically building envelope requires. How we do it? We fly drones around the buildings. We capture hundreds, sometimes thousands of data points. These data points are high-resolution visual images superimposed on high-resolution infrared images. Then on the second step, we do have a proprietary software that sifts through these thousands of data points and finds the problematics area of the building. So we do have an AI-backed software that goes and searches through all of the problems that the previous presenter and also the next will present to you, like thermal bridging, cracks, failed windows, failed frames, what have you. And our AI software finds those. And where our patent is how we can actually measure the effective R value of these building elements, roof, walls, windows, what have you, frames. And then based on what we know about the energy usage and also the temperature inside and outside of the building, how we can create an ROI tool for our clients that they can make a decision and figure out where's the low-hanging fruit, how they want to spend their money as far as retrofit and deep retrofit programs. As I mentioned, our AI-backed software could find different type of problems like inadequate insulations, moisture penetration, window insulation problems, energy channels behind the facade of the building, and also measure the effective R value of these building elements. We're a fast-growing startup. We've done several technology validation by different third parties as far as measuring the effective R values, utilizing the high-tech sensors, and also using the conventional methods. In one of the validations, basically collaborated with us, elements of the building, utilizing the normal assumptions that they do for doing U-value assumptions in energy plus modeling, and also doing the therm methods or finite element modeling, and finally comparing it to the data that we have. We plugged in the effective R values that we gave them, or U values that we gave them, into their modeling that the University of Ottawa made, and we created the energy model, and we compared it to the utility bills with them, which we were off by 2% on that. Now, as I mentioned to you, we're a fast-growing startup. So we've done over 500 buildings, very interesting case studies. We have tons of data at this point on different building elements, over 500,000 data points. We're one of the startups to watch for in 2023 by Toronto Star. We've won multiple pitch competitions and what have you. And we're growing rapidly. I want to jump on a case study here for you. It's a residential complex built in 1984. The client knows that the building, the biggest emission is going through the windows. The windows are single glazed old windows, and they were looking for us to give them the data to see where they can prioritize their budget into fixing these and changing these windows. It's a residential building. Their plan is to change unit by unit, and they wanted to know where is the low-hanging fruit on that. We did the entirety of the building envelope, and we figure out that there's 35% that is preventable in this building. That means that if you bring every building element in this building to the building code, you can save up to 35%. But in this case, I like to switch my screen to a live demo of the product. I'm hoping that you can see this window. This is when we do an audit on a building.
We don't see it yet.
We don't see it yet.
Sorry, I'm gonna just quickly share my screen again. Can you see my screen now? Okay.
We see it now.
All right. So this is a live demo of when we do an audit to a building. And you can see that we create a measurable 3D model of the building. We measure the size of every building element. And then we superimpose what we see as a problem on the building on top of it. So the cells that you see on the building is where our software found problematics area on the building. And then based on the severity of the problem, you can see some of them, they have a yellow border. Some of them, they have a red border. Now I want to click on a section of this and show you just the raw data for you to see what basically you can see the difference in this building. This is a brand new building. It's a triple glazed building that's changed on this unit. And you can see side by side a single glazed building. Now you don't need to be a thermographer to see how good the new window is behaving compared to the old ones. What I want you to pay attention to is although we have this window here that is an older window, has lower R value, and we can measure that R value and give it, but there's a lot more on these windows, what we call area of interest, air infiltration, failed frames, and what have you, that usually we do not calculate on the payback times when we do this throughout conventional energy modeling. At QEA Tech, we can measure the effective R value of this window compared to that window, and also give them an ROI payback. Also, we can create a model for all of these area of interest and measure how much energy is passing through those area of interest throughout the year. I'm just going to go back to my presentation quickly. So that was the case as far as changing the windows. As I mentioned, we've done over 500 buildings. This is a large multi-facility healthcare complex built in the 70s. The amount of air infiltration, also the energy loss from the conductive part of the building envelope is huge in this. The total preventable amount of energy loss, if we had everything to the building code, would be up to 58% in this case. And a lot more. One of the things that is quite interesting, many of the cities and municipalities, they have pledged to get to the net zero to 2030 or 2050 targets, basically. And we don't have data of what are we going to do from architectural point of view on the stock of the building that we're going to have, and they're going to be with us in 2050. So one of the interesting projects that we did for City of Ottawa is to do an audit over a city block. which is a 0.6 mile square downtown block. And we capture a data from each building to be able to benchmark the performance of the building envelope across 250 buildings in 2 block of city block. It's quite interesting to have this data for the municipality to make decision on what they want to do and what do they need as far as incentives for their citizens to achieve the target that they have. The other thing that is quite interesting in our technology is many of our clients, they want to do retrofit or deep retrofit, but they do not have the big capex at this point to attack it. What we offer them is targeted retrofit. We showed buildings. This is a federal building in Canada that we showed them with your maintenance budget that you have, let's say of 100K to 60K of the building. You can set up projects that have 3.3 year payback time or 78 year payback time. That's what I mean by a targeted retrofit program. Now, our technology has other benefits as far as not only calculating the energy loss and ROI tool, but also some sort of predictive measurements as well. In this case, you can see that in this glass tower, we can show the area of energy loss, and also we can show that the insulating gas between the layers of these IGUs are gone, and some of them, and we can say which one is going to go next. Now, we've done a lot of industrial buildings as well. Industrial buildings are notorious in losing energy from building envelope because they have other sorts of energy intensive sources inside the building that usually the property managers, they don't pay attention to it. And some of the fixes to get to it, the energy saving and also reduced energy is very simple. Like the shipping doors are very simple to fix, or other problems that we found in industrial buildings. Now with our technology, we have AI modules to find moisture penetration as well. In this case, you can see that this building doesn't have any problem on the roof, but there's a crack on the wall, and we can show the path of moisture going to the building after the rain. Another case study that is quite interesting for us is to see if we can somehow have an estimation of air leakage in the buildings without doing the extensive blower door test. We did a study with 10 commercial buildings in Winnipeg with Efficiency Manitoba, and we did a 2 methodology using the infrared imagery that we're doing and also the blower door test, which was very hard actually to pressurize the large commercial buildings there. And the results, this is fairly new for us, the new technology that we're developing. We can estimate quite nice the air infiltration based on the infrared imageries that we're doing, which there's no other technology at this point besides doing like very intense modeling of the air infiltration. Non-intrusive and fast technology we haven't come across that can do it. And pressurizing the commercialized building is very hard to do. Now, when we do our audits, we give a lot more information to our clients that sometimes is very important. Roof inspections and other data that is available on the roof of the building is something that we do on a regular basis. Sometimes we come across some very interesting data that our clients they're interested with. Here in this case, you can see ice accumulation behind the facade or the stone slabs in this building. That when our software picks that up, that's it's a huge liability for our clients, and the fix is very easy as far as that problem exists in the building envelope. We work with a lot of big customers, more than 10 billion square foot of real estate handled by our customers at this point. Before I finish my presentations, I just showing the list of what other problems our software could find, and we've already have data over it. Another thing that I want to measure is many of our clients at this point, they start using our technology for measurement and verifications. We do after retrofit examples with our clients to figure out if what the architect designed and all of our friends basically provided the solution, if it's executed properly as well. And we've done very interesting case studies that shows some of our new building does not perform as the older building, that I can share with you during the Q&A. And that's my presentation, Kelly.
Thank you, Pravin. And guys, it's QEA Tech, not QEA Tech. Apologies for that. It's just the Q kind of got me up. I like the way it resonates. Thank you so much, Pravin, for your presentation. Everyone, please, questions, please add them to the chat for the QEA Tech team, and we'll get to them after our final presentation. And now to the final presentation, I'd like to introduce John, who is the CEO at Unitiwall Corporation, and Deborah, who is actually a resilient building advisor at Unitiwall as well. The company is based in Mississauga in Ontario. John has been working on prefab building solutions for a number of years, and with Unitiwall as his latest endeavor. Prior to founding Unitiwall, John also held leadership roles at both Skyrise Prefab Building Solutions and SLB Prefab System. John, please, looking forward to your presentation. Is your video on?
It is.
Super duper. You're on. Take it on.
Thank you. Good afternoon, everybody. Thanks again for the introduction, Kelly. Both Deborah and myself are very happy to be participating here with some of our industry partners. Exciting to see QEA Tech and Cascadia joining as well. We look forward to sharing more about Unitiwall and how we're doing our part towards the decarbonization of the built environment. And next, please. Having spent, as Kelly mentioned, decades in the prefab industry, we've identified, as many have in this space, the growing need for a thermally broken and fully unitized wall assembly that would still allow for the incorporation of premium window and gasket seal systems for the full enclosure. Our fully unitized wall system has been in the product development phase for the last 5 years now. We've just been, this last August, awarded our patents. These are just some examples of our former hobby farm, if you will, where we did the last leg of our product development. Next slide, please. Our wall offerings being considered for both new and deep energy retrofit, and today we'll be concentrating on a deep energy retrofit side. Next. We asked the question, so why prefab? Depending on who the stakeholder is, that means a lot of different things, but the first that comes to mind, obviously, is speed and the levels of quality when you're taking these systems off site and bringing them finished to the field. Durability, resiliency, adaptability. We are a steel system. I'll get into the details in a little bit, but we utilize steel, not aluminum. And we allow for the cladding products that are spec'd by the architects and consultants. So there's no sacrifices to be made there. We're not promoting any one product. We're able to bring them all into the factory and have them completed here. The environmental advantages, many of which has been mentioned. We talk about our built environment and the contributions to the GHGs and carbon footprint. We're kicking around numbers, anywhere between 50 and 80% better performance. So similarly, you can look for those sorts of reductions when we go back to these buildings of the past and bring them up to future code, if you will. We talk about product failures being, the risk for that being mitigated. If there is any sort of damage or failure to any of our cladding systems, the way that we affix them to our wall assemblies allow for just that section to be removed and replaced, rather than having to take out courses and courses of, let's say, an ACM product or whatnot. Our building resiliency and passive house expert, Deborah, will be getting into more of that technical stuff as we get into it, but we talk about life cycle analyses. Again, as Pavan had mentioned, these sorts of durable and resilient products definitely lend themselves to increase increased life cycle there. The design assist opportunities for all stakeholders, whether you're an architect, engineer, or as us, a manufacturer, any of the consultants, constructors, and owners. What we're basically doing here is we're looking at this as a more integrated or collaborative approach. We like to get involved early on in the preliminary design so that we can bring the weight of our experience and knowledge to the table. These are the sorts of things, this early on coordination and design exercise is what really allows prefabrication to shine. The possibilities from a building standpoint to be able to utilize these increased levels of performing products, really, we haven't come across anything yet that's shown as an objection, if you will. We're able to really work with whatever the intent is overall for all those stakeholders. The biggest one, again, coming back to speed, is the mitigation of the labor and trade shortages that are being experienced on a global scale. Our wall systems, basically, depending on how the constructor would be set up, but we're replacing several trades, and the number of people on site to install our system are 6, compared to dozens and dozens of people or bodies that would be required into these various trades. To do this very time-consuming work, if going about it in a conventional method, the way that codes are changing, and from an urban planning standpoint, the way that zoning bylaws are changing, that the footprint of buildings are getting closer and closer to lot lines. It's become difficult to even put up a baker scaffold, let alone the proper staging that you need on the exterior of a building to do these sorts of high-performing systems in the conventional way with those multiple trades. So one of the biggest, outside of the environmental advantages for this green technology, one of the biggest and most well-received propositions is on the time side and logistics. We are drastically reducing that construction schedule and getting these buildings dried in, usually typically about 80% quicker. With respect to Unitiwall's adaptability and flexibility, I've basically gone through all of these in my discussion when talking about the items on the left. And for those that don't know, the Illinois Green Alliance will be making this presentation available to anybody who's interested. So I'll leave it to you to go through it in more detail. If you could go to the next slide, please. So our wall offering is an alternate to traditional aluminum curtain wall systems. Early indications and with respect to what our pipeline is looking like these days, and it's an unsolicited pipeline. We haven't even formally announced our company, but we are more than successfully able to compete with the likes of Mega Panel and Speedwall, some of these other higher performing systems that are currently coming out in a fully unitized way. What we're essentially doing is, at the bottom there, you'll see, taking this traditionally complex and time-consuming system, which utilizes multiple trades, and taking it off-site and being able to fully unitize it. It is 100% non-combustible. We have true rain screen functionality, and we'll get into the details of the panel in the next slide. We are compatible with any hard cladding systems that are spec'd currently, and compatible with all window and glass curtain wall systems. We are 501 tested, airtight and water impermeable. We allow for the complete installation, depending on the size of the panels. We can do the complete installation from the inside of the building as well. We are considered bridge-free, and we utilize the mineral or stone wool product on the exteriors to achieve high effective R values, as Mike was talking about. And we utilize no aluminum framing components, as I've mentioned. It's all cold form steel and or stainless steel products. With respect to cost effectiveness, for those that might be wondering, we're in line with what traditional high performing curtain walls are being offered up today. Next slide, please. This is a simplistic view. We are basically a dual frame system. So at the very top on the right there, we're referring to the structural frame. It's a horizontal membered assembly. So we're, the stud, if you will, which, they're not traditional studs. We do roll form all of our own steel components, but that U-channel design is in a horizontal way. You'll see some examples in later slides. It is sheathed with, through the use of silicone adhesive. It is sheathed with a stainless steel or cold form steel sheet that acts as our AVB and also provides rigidity to the structural panel. On the outside, we have, and you see the cutaway there at the right-hand corner of our plenum, our thermal plenum, which is the patented part, along with some of the other mechanical fasteners, if you will, that bring the two frames together, has been cut away to reveal that sheet steel. But the plenum is put together in vertical fashion. And it's within that plenum that we house, whether it be a 5, 7, or 9-inch stone wall. So we have 3 different thicknesses for the plenum, 4 7/8, 5 7/8, and 8 7/8. And proud of that would be the air channel that allows for the ventilation and pressure equalization. And then outside of that, we have our panel strut, which is here. And that allows for us to affix most of the products that we're talking about being offered through this wall system. When we're talking about glass, if we wanted to do an all glass panel, that would be affixed directly to our plenum. The plenum has drainage holes at the window head and at the bottom, and on the sides are the ventilation holes that would allow for the drying of those areas and allow the water to be managed. Again, we mentioned any cladding. I don't know if we can say any cladding, but we've not come across any that aren't able to be utilized in our system here. We can go to the next slide. So one of the critical areas, windows, and then of course, the joints. So we have a patented extruded silicone gasket system that's ASTM tested, as I've mentioned, 501. That has quite a bit of tolerance in it. Our vertical joints at rest are 1.5 inches wide, and our horizontals are 2 inches wide. Once the panels are installed, they are 1 inch and 1.5 inch accordingly. So for the vertical and horizontal, we have about a 3/4 inch forecasted tolerance, and that's just being validated in part of our final testing with Morrison Hershfield. And what this allows to do is to factory install 2 sides of the panel with the seal system. And then in the field, we're doing the remaining work as we bring in panel to panel. Next slide, please. Here are just a few pictures showing the various products. The panel on the left is utilizing a product from our friends at Muralis Architectural out in Vancouver. It's a product that we're going to be using on one of the first projects that we've signed here in Toronto, and incorporates a triple glazed window system. And then the 4 on the right, ACM, and then going clockwise is a corium brick product, GFRC, and then a sintered product, the black one there with the different coloring. Just to give an example of some of the products that can be utilized. Next slide, please. So very similar to typical curtain wall. We have pockets that allow for the introduction of our gravity connectors. And at the bottom of the panels, we have slip connections. Here we're showing an example of a cast in place or formed floor slab. But again, we are not limited structurally, so it could just as easily be a mass timber or red iron structure or hollow core, or even some of the composite steel decking systems that are out there. The next slide shows, Paula, if you could go to the next one, is zoom in. So this pocket, so we supply the unistrut that's shown there on the right. So that's embedded by the formwork contractor, and then we come in with our angular plate and bolt that in. And to that, we affix our gravity connectors. And you see the leveling bolts there. This allows for a 6-way adjustment, if you will. So side to side along the unistrut, front to back, you see the slots there in the support angle, and then of course we have the leveling bolts in the gravity anchors. And then once those are set, we remove those bolts, and nobody can mess with those. Next slide, please. At this point, I'll turn it over to Deborah.
Thanks, John. I think many people have addressed high performance buildings, or the use or the want to design and build a high performance building today. But I think there are a few perceptions of what it is. Some think it's just energy performance. Some think it's to do with carbon footprint. And then some things it's to do with the building stamp. I think in today's market, it can be one or all of those things. And the Unitiwall system itself can actually address most of the requirements of the major building standards or building certificates that are out there. So yeah, it can address the zero carbon building because we'll be tracking our embodied carbon. Net zero energy, because we're obviously looking at a low energy system, while in passive house for their requirements on efficiencies and comfort, Retrofit obviously from a retrofit of a passive house, and the living building challenge, because we're currently looking at on our declare label. The low energy is addressed in the enclosure, obviously, because our system allows for that full high level of insulation in one complete layer. The metal air vapor barrier that is there is also a complete seam, and with the silicone gaskets between the panels creates that complete air tightness seal. It's obviously thermally broken through our thermal isolators, and we're in the pursuit of a passive house certification at the moment. The manufacturing of the wall itself will be done in a lean manufactured process using all of the best and most efficient processes that are available, and as recommended by the CSA. The power that would power the plant is the majority comes from either renewable resources or clean energy. The material will either be mostly recycled or from a low carbon source. And we we're, as I said, we're working on the EPD declarations there too. Next, please. So I grabbed this from the CSA, and it's an interesting layout of an optimal modular factory operation. And it focuses obviously on the benefits of prefab, but also it notes that good prefab promotes environmentally responsible building practices. And that's what we're trying to do within the Unitiwall system. If you look at the graphic, it has a very organized operations, and it accesses buildings in the vicinity through, the cleaner transportations and so on. And so at Unitiwall, the placement of the factory actually also supports this. Next, please. So this is our current location in Mississauga, which is an urban site. It is almost the real life example of the CSA optimal illustration. We have our factory plant and facility, our corporate offices. This is where the steel frame manufacturing will be complete. Our storage, and I don't know if you can see properly here, is the rail spur. So we've got access to the rail here, Sorry, I'm pointing at the screen, realizing you can't actually see my mouse. But the little circle shows where the railway access is. Obviously, you can see the road to the left of that is the highway, and just beyond the highway, on the other side of the highway, is access to the lake. I don't know if many of you know, but the Lake Ontario is a shipping route to the Atlantic and through the northern states of the US. And then on the left of this, or sorry, on the right of the screen is just the facility setup that we have for completing the panels. Next, please. Yeah, so just to say here that we have, this is our baseline R value, our U values for the wall buildup. I've just highlighted the green box here with the highest R value we have for the baseline wall. This is the platinum is mostly all stainless steel and the thermal platinum, and at their baseline we can meet that or value of 25.2. And like I said, this is a baseline, so we're starting, this is more or less our starting point for the majority of our projects so far. We're finding we can go higher, but you know, there's always a balance between achieving incredibly high on the R value versus the embodied carbon. Next, please. I've got a note to talk faster, so so just where in the world. So just wanted to highlight the fact that while we're building walls in Canada, the majority of the climate that between Canada and the US is similar, and so the development of the wall and the ability for the wall to meet the climate zones that are available or that happen in North America, the Unitiwall can meet those requirements. Next, please. And just quickly, this is a study of a wall that was modified from our baseline, and the requirement was to go as high, go higher on the U value while also monitoring the effect of the humidity in the space. So it's a hospital, and they would have special humidity levels giving the conditions that they need for certain patient and treatment rooms. And so you can see we have an R value of R35, which is very close or getting closer to that pacified standard. And in rooms with an almost optimal relative humidity, but with extreme cold on the outside. Next, please. And this is just to show what we tested on the wall. So we had tested the 3 worst junctions within the wall itself. So the T1, T2, T3 are the worst connections within the wall that are most likely to suffer with the dew point. And obviously that T1, T2 changes location within the wall. And then just to say here that yeah, sorry, you can go to the next page. I've just got another warning to talk faster. So ultimately here, we're just showing that with any buildup of the wall, we can meet the requirements. So with the relative humidity being adjusted, we can stay above the dew point. So the dew point at those 2 or 3 conditions in each buildup of wall, we're in the 7.8 area or temperature, and in all cases we stayed above that, so there was no risk of condensation within the wall itself. Next, please. And this is like the opposite. So this is just to show what the relative humidity within the space causes, so where the risk would be, so what our risk is with the relative humidity. So if we drove the humidity up in the space, does it affect the wall? Next, I think, is John.
Thanks, Deb.
I think we're out of time.
Yeah, I'll just leave this with just real quickly. This is part of the presentation. After we softly launched or put out the word at Passive House Canada's annual conference last year that we were offering this wall system to the market. Within 6 weeks, we had signed this first project. It's a mass timber building. For anybody that's ever designed or understands those structures, they move around a lot, and our panel was the only one that they could find that it could accommodate the tolerances that were required. If there's any other questions, we'll leave it for later, but thank you very much for the opportunity, everybody.
Thank you, John and Deborah. Great presentation. And for everybody, please don't forget, the presentation is going to be available, and Katie will be able to present that to everybody. I would like to invite all our presenters to turn their cameras back on for some quick discussion. We don't have a lot of minutes for questions. Kate is going to check the chat for questions, so please continue to place your comments and questions in there as well. Okay, great. Just real quickly, for those of you who did not actually know, Deborah, I'm just going to read your blog real quickly. She's actually experienced in developing innovative building solutions, building materials for large-scale, high-performance buildings, and she's also a key investigator in the development of Passive House across Canada, being a founding director and board chair emeritus of Passive House Canada. Deborah, I have a quick question. You showed really quickly the basically the climate zone for Canada, all the way from the Atlantic provinces to British Columbia, and this is all based on the heat and degree days. Just real quickly, in a couple of people who are on the line, what does that HDD or heat and degree day based on 16 degrees Celsius actually represent?
It's the number of degrees that a day's average temperature is above 65 degrees Fahrenheit or 18 degrees Celsius.
I appreciate that. It was good to get that in there. All right, Mike, I'm just going to go back to you real quickly. So I know you have a lot of experience in the building industry. I checked that you worked as a glazier and a carpenter. And through your time as a building science technologist, you also teach in architectural engineering at British Columbia. You use fiberglass resin for your system, though. What is it about that particular material that makes it, I think you guys quoted about 250% improvement over the traditional aluminum. What's that sweet spot? What's that secret sauce that goes in there without obviously giving away the trade secrets and intellectual property?
Right. So essentially all of our products are primarily fiberglass, and fiberglass, it consists of a thermoset resin, which is different than a thermoplastic, and it's different than a metal. So the key benefits to using fiberglass and the associated resins is that it has a very low conductivity relative to metal products. So there's less heat transfer through conduction through the actual material. Some of the other key benefits with fiberglass is it's a very strong material relative to thermoplastics like PVC. You can incorporate glass fibers through the profile that make it really strong. And the other key benefit over thermoplastics is that it's more stable and more durable. So it's not affected as much by thermal changes. So there's not a lot of thermal expansion and contraction throughout the service life of the product.
Thank you, Mike. Kevin, can I ask you a quick question? Sure. So obviously we mentioned about CapEx projects, building envelope being, what's it called, about 51% of the building's energy loss is through its envelope. What does a building need, or what conditions do you guys need to actually be able to run your thermography and your analysis process from start to the deliverable to the client?
So what we do, Kelly, is very non-intrusive. What we need is a delta T of 10 degrees C or 18 degrees Fahrenheit between inside and outside when we do our quantifications. So for most of the cold states basically would be from September to May, and for the hot states would be more on the summertime for us to do this analysis. We do 1 hour of operation at night, 1 hour of operation during the day, and that will be sufficient for us to capture the data for a fair size building, like a 20-story building for us to do. And we send a prerequisite form to the property manager to fill out before that. And the information that we need basically is the energy usage and the temperature set throughout the year.
Thank you so much, Pavan. John, I have a question for you real quickly. I know that you've been in the trade and you've worked on panelized systems in the past. I think your system right now is a 10-foot by 14-foot kind of framing. There might be some architects that say, oh, that might be restricting us from an architectural standpoint. Could you just talk a little bit more about the flexibility of the Unitiwall system and the different types of surfaces and facades that you've been able to affix to that, and why that should not be an issue?
We do have, similar to the curtain wall industry, we do have what we'd like to see by way of, typical size, whether it be 8 or 10 foot wide by, your floor height, whether it be 10, 12, 14. That's not to say that we can't build bigger panels. On the U of T project, we have some that are approaching 24 feet in length. Our problem is one of logistics. How do we get it to you? So a number of the projects that we're currently looking at with the same constructor being Pomerleau, we're on 4 different hospital projects, and they're all, across Canada. So we're kind of trying to find that balance, if you will, with respect to what we can ship by rail, land, or by water, because we are also, as Deborah mentioned, looking at doing some stuff up to Moosonee through Hamilton, which is on Lake Ontario.
I appreciate that clarification, John. Mike, just back to you real quickly, if you don't mind.
Yep.
You mentioned as part of yours, you had a triple glazed window option with an R value of 7.1, and then you also added a premium triple glazed window option with an R value of 7.7. So those are obviously very, very impressive kind of numbers. Can you just talk about what's the difference between either of those two options?
Yeah, so the difference between the base triple glaze product that hits the 7.1 and the one that hits the 7.7 is the addition of a third low emissivity coating to the IGU, so to the insulated glass unit. Usually in a triple glazed IGU, there are 2 low E coatings, one in each of the air spaces, but in our premium option, we can provide a surface 6 low E coating, which is on the interior most surface of the IGU, and that gets you to that elevated R value level.
Thank you for that clarification, Mike. Question for John real quickly. I see it's actually in the chat. What are some of the biggest challenges to reducing carbon emissions in your construction process? You mentioned that you use mainly renewable or clean energy. Do you know the specific breakdown of what type of energy sources are used and what percentages come from and where? It's a bit of a challenging question, and but take a chance at it.
Yeah, not quite yet. I understand the question is something I think Deborah would probably be able to answer easier, as she's the one charged with kind of getting us through the EPD and declare phases and working closely with Passive House towards our certification. But we do use, as I've mentioned, cold form steel primarily, which is locally sourced, 85% recycled materials. So it's all post-consumer scrap, refrigerators, cars, all that fun stuff. And many of the materials that we're using are recyclable. And the wall system itself is demountable and then ultimately recyclable. So, I mean, these are all things that we take into consideration when we talk about embodied carbon. Deb, I don't know if you want to add anything to that.
Sorry, I missed the beginning of the question because I was writing an answer to another in the chat.
No problem, Deborah. It was really about the renewable credentials of a Unity system, the Unitiwall system based on.
So we it's exactly what John said. It's all of the material will be validated through our EPD or life cycle assessment and the declare labels. So they will all have different levels of recyclable content, and it's in development.
All right, so we're going to have a final question before we wrap up. It's for Pavan. Real quickly, I know that a lot of people are considering maybe partnerships. So a good colleague of mine, Jason LaFleur, has a question about QEA Tech. are you guys open to partnerships with other collaborators for the drone technology and the building energy audits of the building envelopes? And can you just talk us through real quickly how that partnership potentially could work?
Absolutely. So we already started going to the US market. We just did 45 buildings for Brooklyn Libraries, and we do have partners, drone operators in all the states to do the operation on our behalf. And we're open to partner with other parties. It depends on what level of partnership they want to do. If they want to do the data collection, we're happy to do that. We're a software company. They can upload their data in our platform, and we can give them the analytics, or we can do the entirety of the project, including the operation and data collection there. But we do have at this point drone operators, trained drone operators in all the states in the United States to do these projects.
Thank you very, very much. I'm going to hand it back to Katie now. But before I do that, I wanted to just say thank you to all the presenters and all the different systems that were actually kind of described today. And I found it really, really interesting. And I'm hoping we will get some more company and technical information as part of this presentation. Over to you, Katie.
Thank you, Kelly. Thanks so much for moderating today's session. You did a wonderful job as usual. Thank you to all of our speakers for sharing your technologies and your best practices and your lessons learned with our attendees today. I wanted to just note that after the session today, you'll be receiving a follow-up email in the next couple of days with a summary of the Q&A. So in case you missed some of the answers to the questions that were written in the chat and in the Q&A, we'll share those. We'll send a recording of the webinar, so you can share it with all your friends and colleagues that missed it, as well as a PDF of everyone's presentations today. We'll also be sharing everyone's contact information at each of the companies so that you can follow up with them directly if you have questions about how to work with them on your projects in the future. Thank you again, everyone, for attending. I'm going to turn it back to Anne Rosen from the Canadian Consulate in Chicago to just say a final thank you as well.
Hello, bonjour. Can you hear me?
Yes.
Awesome, great. I'm Anne Rosen, the lead on infrastructure at the Canadian Consulate General in Chicago, with my colleagues in Minnesota and the Canadian Embassy. Maybe they could turn their cameras on so people know who they are. We are part of the Canadian Trade Commissioner Service, and our job is to assist local firms like yourselves in making connections with Canadian companies, such as the 3 companies that we have here today. I want to thank Mike, Pavan, John, and Deborah. They are 3 of 52,000 companies that specialize in this area. So if you are looking for any opportunities outside this, think of us as a resource, a shortcut to helping you find the technologies you need. I think that Katie will put our email information, maybe when she says the package out, but we're basically happy to help you in any way we can. Now, if you enjoyed today's session, we will host part 2 of this on new construction, energy efficient technologies, focusing in on new construction, such as heat pumps and other technologies. So that is going to be on, mark your calendars for March 21st. I think it's a Wednesday or Thursday. And watch IGA's website to register. Again, we look forward to seeing you at our 2nd series. And thank you, merci, and have a great day.
Thanks, everyone. Thanks, Anne.
And thank you, Kelly.